Hello and welcome to another Algebra 1 lesson by eMath instruction. My name is Kirk Weiler and today we'll be doing Unit 7, Lesson 4 on more work multiplying polynomials. Now, we started working with multiplication of polynomials in the last lesson, and we concentrated on multiplying a binomial by a binomial, right? A two-term polynomial by another two-term polynomial. And oftentimes, those binomials were linear. In other words, the power on the x or the m or the t or whatever the variable was just to the first. We're going to be looking at that even more today and kind of expanding our abilities in multiplying polynomials. But let's begin by looking at more multiplication of these binomials. Very, very important. Now, we've seen a variety of techniques to multiply binomials, but they all really boil down to one single method, which is what's known as double distribution. When we multiply two binomials, we're really just using the distributive property twice. In fact, that's what you've always done when you've multiplied two-digit numbers. You've used the distributive property twice. You probably just didn't even realize it. So let's learn how to do double distribution as sort of our final technique in how to multiply binomials. Let's take a look at exercise number 1. Find each of the following products by using the distributive property twice. The first is started for you. Letter A, 2x plus 5 times 3x plus 2. Awesome. So let's talk about how we begin a double distribution. Some of you really may prefer double distribution in terms of how to do this. We're going to review all 4 methods in the next problem. But here, right, what we have is we've got these two things multiplied by these two things. Now with distribution, we typically take this and multiply it through these two. What I'm going to be doing is I'm going to be taking 2x and multiplying it by 3x plus 2, and then I'm going to take positive 5 and multiply it by 3x plus 2. So I begin with this 2x times 3x plus 2 plus 5 times 3x plus 2. Now, how do I proceed? Well, let's do it. Right? So at this point, what I'm going to do is I'm going to distribute my 2x, and I'll have 2x times 3x, which is 6x squared, right? Then 2x times 2, which is 4x. Now, plus, I'll distribute the 5 through. 5 times 3x is 15x, and 5 times 2 is just positive 10. Just like when we FOIL two binomials, the only two terms that we can combine are those middle two terms. 4x plus 15x is 19x plus 10. Right? That's it. And it's basically this simple. Every term within one parenthesis must multiply every term within the other parentheses. And so we just simply say, well, I'm going to take the first term in this parenthesis and I'm going to multiply it through this one. Then I'm going to take the second term in this parenthesis and multiply it through this one. Let's do another one together. Let's take a look at letter B. 7x plus 3 times 5x plus 4. All right, let's take a look at double distribution together right now. Here we go. So to begin, I'm going to take 7x and I'm going to multiply it by 5x plus 4. And then I'm going to take 3 and multiply it by 5x plus 4. Each one of these problems is pretty easy by itself, right? 7x times 5x is 35x squared. 7x times 4 is 28x. 3 times 5x is 15x. And 3 times 4 is 12. Give myself a little bit more room there. All right, the 35x squared can't combine with anything. The 28x plus the 15x is, let me think about that a little bit, I think 43x. And then nothing combines with that constant of 12. Again, I want to keep pointing out the fact that when we multiply two linear binomials together, I know that's some fancy terminology there, but when we multiply two linear binomials together, in other words, this one's highest power is x to the first, this one's highest power is x to the first, then at the end of the day, we end up having 4 terms, right? And of those 4 terms, sort of these two terms, right, will combine with the quadratic, the squared term, and the constant term sort of being left alone. And most of the time, when we multiply two linear binomials together, we end up getting a 1, 2, 3, a trinomial polynomial, also known as a quadratic polynomial because the highest power is squared. Let's do one more together that's got a little bit of negative or subtraction going on in it, and then I'll have you do 3 on your own. Let's take a look at letter C. In this case, we have the binomial x minus 4 times the binomial x plus 8. So let's do it. Now the subtraction's not too bad. All I need to do in this case is I will first multiply x plus 8 by that x, and then I'll multiply x plus 8 by negative 4. Again, distributing this x first, x times x is x squared, and x times 8 is 8x. Here, I really want to think about this as multiplying by negative 4. So negative 4 times x is negative 4x, and negative 4 times positive 8 is negative 32. Just like before, right, I've got these two terms right in the center of my multiplication that combine. 8x minus 4x is just 4x, and then negative 32 is negative 32. Whoops, there we go. All right, so pretty easy, right? Double distribution, taking everything in this binomial and multiplying it by everything in this binomial. The procedure is basically the same each and every time you do it. So what I'd like you to do now is pause the video and go ahead and work through each one of these. Each one's got a little bit of subtraction in it, so that might throw you off. Watch out, remember a negative times a negative is a positive. That's going to come up in this particular one and this one. So be careful with that, but why don't you pause the video now and take a few minutes to do these three remaining problems in exercise 1. All right, let's do x minus 5 times x minus 2. Here we go. So I'm going to have x times x minus 2 minus 5 times x minus 2. All right, in the first case, we have x squared minus 2x. And in the second case, we have negative 5x plus 10. Again, that plus 10 comes from multiplying a negative 5 by a negative 2, giving me a positive 10. Be careful here, I have a negative 2x and a negative 5x. Combine those together and I get a negative 7x. And finally, we have plus 10. All right, let's take a look at letter E. In this case, we will start off with 3x times x minus 7 minus 4 times x minus 7. All right, 3x times x is 3x squared. 3x times negative 7 is negative 21x. Negative 4 times x is negative 4x. And negative 4 times negative 7, again, we need to be careful here. That's where a lot of students will make a mistake, is positive 28. Nothing combines with my 3x squared, and negative 21 and negative 4 combine to be negative 25x plus 28. All right. Now, our final one, something a little funny happens. And we're going to concentrate on this in the next lesson, I believe. We're going to multiply first by x times x minus 9, and then positive 9 times x minus 9. All right, x times x is x squared, and x times negative 9 is negative 9x. 9 times x is positive 9x, and 9 times negative 9 is negative 81. Now, before I finish this, I want to kind of take a look at this because this one's going to really break the pattern of all the other ones we've seen. In every other case, the resulting product, the thing that we came out with at the end when we multiplied everything through, was a trinomial. Tri, 1, 2, 3, 3 terms, 1, 2, 3. This one's going to turn out to be a binomial because negative 9x and positive 9x are equal to 0, right? Those are what are called additive inverses or additive opposites. Negative 9x, positive 9x literally cancel each other out, and we're left with x squared minus 81. And that's a little bit different, and we're going to really investigate that pattern quite a bit in the next lesson when we talk about what are known as conjugate pairs. But for right now, just realize that sometimes when you multiply two binomials together, you will not get a trinomial, but you'll actually get another binomial. All right, let's keep going. Double distribution is really amazing, all right? But at the end of the day, what I need you to be good at, and pretty quickly, is multiplying two binomials together. And we now have 4 techniques to do it. So let's do some comparing of multiplication techniques. We've now seen 4 different ways to multiply two binomials together, and it's interesting to compare each method for the same product. I mean, we could do all 4 methods for different products, but I kind of want to see how all 4 play out using the same pair of binomials that we're multiplying together. So let's take a look at that in exercise number 2. Consider the product 3x plus 5 times 2x minus 9. Find the resulting polynomial using all 4 techniques. So let's talk about the 4 techniques, and then since we've done all 4 of them within the last lesson and lessons, right, this one and the last one, I'd like to have you work on all of them on your own, right? We've got the standard multiplication algorithm, which is similar to multiplying two-digit numbers. We've got the area model, which is really great because it kind of keeps track of all of your different sort of products. We've got the FOIL method, which, to be honest, is probably the most common one and the one I will use the most often. And then there's double distribution, which to me is really where all the techniques come from, but really kind of formally doing it that way. So what I'd like you to do, and look, let's be clear about this. You should get the same answer on every one of these 4 problems. What I want you to decide on when we get done with this problem is which technique do you like best? Which one do you want to use? You're not likely to be forced to use any one of these particular techniques in a particular problem, but you want to be able to use at least one of them, and so you kind of want to decide on what your favorite is right up front. So pause the video now and see if you can work through each one of these 4 methods to get the final answer. All 4 answers should be the same, and then we'll go through each one of the 4 techniques. All right, let's first do the standard multiplication algorithm. Now remember, for doing that, we're going to first take this -9 and multiply it by 3x plus 5, just like we would if this was, let's say, 35 times 29, and yeah, I know that's a negative there. But we're first going to multiply all this by -9, then we're going to put a 0 down and then multiply everything by 2x as well. All right, so here we go. First things first, I'm going to take a -9 and multiply it by 3x plus 5. That would be negative 27x minus 45, right? And just like the standard multiplication algorithm, I now put down a 0 as kind of a placeholder. Now I'm going to take 2x and multiply it by 3x plus 5. That's going to give me 6x squared plus 10x. All right, I now add these two together just like I would in the standard multiplication algorithm. Negative 45 plus 0 is negative 45. Negative 27x plus 10x is negative 17x, and 6x squared plus 0 is 6x squared. All right, we're going to get 6x squared minus 17x minus 45 on every one of these things, right? But again, we just want to see that technique. All right, let's now jump to the area model. Okay, in the area model, the first thing I'm going to do is take my 2x and multiply it by my 3x, and that's going to be 6x squared. Then I'm going to do 2x times 5 and get 10x. Now I'll do negative 9 times 3x, and that'll be negative 27x. And now negative 9 times positive 5, which is negative 45. Remember, when we use areas, the only 2 things we're going to be able to combine are right there. We just want to add everything together. That's going to be 6x squared, negative 27x, positive 10x is negative 17x, and negative 45 again. All right. Again, notice some themes here, right? One of the themes that we keep seeing is that the only 2 things that are combining are those 2 linear terms. In the case of the area model, they come along the diagonal. In the case of the standard multiplication algorithm, they come right here in the middle when you add those 2 things together. Now let's take a look at foiling. As I mentioned, this is probably the most common of the methods. Some math teachers absolutely hate the acronym because students get to learn it so well that, as I think I mentioned in the last lessons, they sometimes call this foiling 2 binomials as opposed to multiplying them. But here we go, right? FOIL stands for first, outer, inner, last. First means that we're going to multiply the first 2 terms in the 2 binomials. 3x times 2x is 6x squared. O means we're going to multiply the outer 2 terms. 3x times negative 9 is negative 27x. I means that we're going to multiply the inner 2 terms. That's 5 times 2x, which is positive 10x. And the L means we're going to multiply the last 2 terms. 5 times negative 9 is negative 45. Here, we can now combine these 2 middle terms, and negative 27x plus 10x, as it has been in the last 2 situations, was negative 17x, and then we get our negative 45 again. All right. Ideally, you want to get so good at foiling or area or whatever that you can almost do it in your head, right? It's always going to be 4 terms, 2 of which are going to combine to give you a linear term here. All right, finally, let's do double distribution. That's the one that we took a look at today. Double distribution says, okay, I'm going to start this problem off by taking my 3x and multiplying by 2x minus 9. And then I'm going to take my 5 and multiply by 2x minus 9. All right, 3x times 2x is 6x squared. 3x times negative 9 is negative 27x. 5 times 2x is 10x. And 5 times negative 9 is negative 45. Again, combine these two terms, 6x squared minus 17x minus 45. And that's it. And I promise you, in general, that will be it. We will not introduce a fifth or a sixth way of multiplying two linear binomials together. But as any math teacher or any math student who's gone through all of high school math can tell you, this is an amazingly important skill that comes up an unusual amount of times in algebra throughout courses. It's amazing how often you have to multiply two binomials together. So let's kind of keep working with this and do more work with multiplication. Now, multiplying a binomial by a trinomial starts to break out of the method. There's no way to use FOIL anymore. There is no FOIL when you multiply a two-term polynomial by a three-term polynomial. But we can sometimes still use some of the techniques. Now, sometimes we will need to multiply more than two binomials together, such as a binomial with a trinomial. Area models can be very helpful for this, as can double distribution. So we're going to take a look at both of those processes in a moment in exercise 3. Let's take a look. In this case, we've got 3x plus 2 times x squared plus 6x plus 8. All right, we want to find the product using an area model, and we'll also find the product using double distribution. All right, both of these techniques are going to work just great. Let's take a look at both. Now, I've drawn the area model here for you. Again, it will be rare, if ever, that will be provided for you, but it's simple enough, right? If I've got a binomial by a trinomial, then I kind of want like a 3 by 2 rectangle that's all kind of divided up. And here's how I'll do it, right? I'll put my 3x here and my positive 2 here, just like I would have with my binomials. I'll put my x squared here, my 6x here, and my 8 here. If you want to put the little pluses in front of them, that's fine too. And now we do the same thing we have been doing. I'll do 3x times x squared, which will be 3x cubed. I'll do 3x times 6x, which will be 18x squared. And I'll do 3x times positive 8, which will be 24x. Then I'll do 2 times x squared, which is just literally 2 times x squared. Then I'll do 2 times 6x, which is 12x. And then I'll do 2 times 8, which is 16. Now notice, when I multiplied a binomial by a binomial, 2 terms times 2 terms, I got 4 terms in the product. Here, I do a binomial times a trinomial, and I get 6 terms in the product. But there's way more I can combine now. The great thing, though, is that the things I can combine still lie along the diagonal. In other words, I can't combine anything with the 3x cubed because there are no other cubed terms. I can't combine anything with the 16 because there are no other constant terms. But these 2x squared terms can combine, and these 2x to the first can combine. So our final answer now will be 3x cubed. 2x squared plus 18x squared is 20x squared. 12x plus 24x is 36x, and nothing combines with the 16. And that's it, right? Area models are amazingly, amazingly helpful in a situation like this. In fact, you could even conceive of multiplying a trinomial by a trinomial, right? There would just be an extra row of squares down here, and you'd have sort of 3 terms here, 3 terms here. You'd have 9 terms overall. There'd be a bunch that you'd have to combine. But the cool thing is all of the like terms would again lie along these diagonals. It's really, really kind of neat. Now, one of the disadvantages of an area model is it's kind of bulky. You got to draw a picture, you got to take up space with all of that. So let's take a look at how we can use double distribution from exercise 1 to do this as well. Here we go. So in this case, right, with double distribution, what I'm going to do is I'm first going to multiply my trinomial by 3x squared. Then I'm going to multiply my trinomial by 2. By the way, if this seems like it's the same thing as what we did in the area model, that's awesome, because it is, right? The first thing I did in the area model was multiply everything in my trinomial by that 3x. So this is going to look very familiar. right? 3x times x squared is 3x cubed. 3x times 6x is 18x squared. 3x times 8 is 24x. All right, now I can distribute the 2 here. 2 times x squared is 2 times x squared. 2 times 6x is 12x, and 2 times 8 is 16. Now, one of the disadvantages of double distribution, one of the advantages is it doesn't take up as much space as this does. One of the disadvantages is that it's harder to see the like terms, right? Here, 18x squared and 2x squared are sort of separated, if you will, by that 24x. Keep in mind, though, this is all addition, so I can rearrange any way I want. And if I wanted to, I could rewrite, or I could write an extra line, because I've got the space. I could rewrite this as 3x cubed plus 18x squared, plus 2x squared plus 24x plus 12x plus 16. And now, right, I can kind of use that associative property of addition, which will allow me to then combine those two into 20x squared, combine those two into my 36x, and that constant and that cubic term still don't combine with anything else, right? Again, which method do you have to learn? Which method do you have to use? You can really do either one of them, all right? Generally speaking, we're not going to tell you you gotta multiply two binomials or a binomial and a trinomial or whatever with one or another particular method. But it's good to have a variety of tools in your tool belt so that you can reach for whichever one is most comfortable to you. All right, so let's kind of keep going. Exercise number 4. Find each of the following products using an area model or double distribution. Show your work and state your answers in standard form. All right, well, we did just do an area method and we did a double distribution method. What I'd like you to do is pause the video now, use whichever technique you want. As a side note, I think I'm gonna do, I think I might do double distribution on letter A, and I think I'll do an area method on letter B just to get them both in there. I won't do both on both of them because it'll take up too much time, but I'd like you to pause the video now and see if you can work through these two products. All right, I think I said I was going to do area here and double distribution here. No, I was going to do double distribution then area. Okay, I want to keep that right. Okay, so double distribution on this one. The first thing I'm going to do is I'm going to multiply my trinomial simply by x, and then I'm going to multiply my trinomial by -2. Give myself some space. So I'm going to distribute my x. X times x squared is x cubed. X times 4x is 4x squared, and x times -3 is -3x. Just be real careful. Right now I want to think about multiplying through by -2. -2 times x squared, -2x squared. -2 times 4x is -8x. And watch out here, -2 times -3 is +6. Nothing combines with that x cubed. I have a 4x squared and a -2x squared. Those will be combined to be a +2x squared. I have a -3x and a -8x. Those will combine to be a -11x. And nothing combines with that constant. All right, x cubed plus 2x squared minus 11x plus 6. All right, let's take a look at letter B, and I'll do this one with an area model. We'll see where we get on that. All right, here we go. Little area model. I'm going to draw out a rectangle. All right, kind of divide it up like that. I'll do 2x and plus 3 here. And I'll do 3x squared minus 5x minus 7. Here we go. 2x times 3x squared is 6x cubed. 2x times -5x is -10x squared. 2x times -7 is -14x. 3 times 3x squared is 9x squared. 3 times -5x is -15x. And 3 times -7 is -21. Notice my like terms now along those diagonals, right? That'll give me 6x cubed. 9x squared minus 10x squared is -1x squared. I'm just going to write it as -x squared. Negative 15x and negative 14x is negative 29x, and nothing combines with my negative 21. All right. Cool. Again, I kind of prefer double distribution over the area model only because for me it takes up less room, although to be honest, these seem to have taken up the exact same amount of room. I still will tend to go with this one a little more. Now, don't get me wrong, if I had to for some reason multiply a trinomial by a trinomial, I think I'd go with area, right? Because in that case, you wouldn't be doing double distribution, you'd be doing triple distribution, which is fine, you could do that. All right, but like, I think that the area model in a 3 by 3 kind of square would work better if I had to do that. Don't worry, we're not going to throw one at you like that, and I don't think you'll see one on a standardized test. This is probably about as bad as you get. Now, this all leads us to one last thing we're going to do. We can certainly have the product of 3 or more polynomials, right? Just as we can have the product of 3 or more numbers. Up to this point in time, we've only multiplied one polynomial by one polynomial. Right? As with numbers, we want to keep going back to normal numbers because algebra basically is just doing with expressions and variables what you do with normal numbers. But the key will be to find the product of 2 of them first, and then once you have that, take that product and multiply by the last one, right? And again, before we even jump into this, this is no different than if I had something like 2 times 5 times 3, right? If I had 2 times 5 times 3, the way I would do that is find the product of 2 of them, like 2 times 5, get 10. Then take 10 and multiply it by 3 and get 30. Or I could do 5 times 3 and get 15, and then multiply it by 2 and get 30. I mean, I could even do 2 times 3 and get 6, and then multiply by 5 and get 30, right? So the key in something like letter A or letter B, both of which are the product of 3 binomials, I first need to find the product of 2 of those binomials, it doesn't matter which, and then multiply it by the third one, all right? So let's take a look at how that's done in letter A, and then we'll have you work on letter B on your own. Exercise number 5, letter A. X minus 4 times x plus 3 times x minus 5. All right, now for me, for whatever reason, I really prefer to first find the product of these two. All right, I always like to find the product of these two and let this one kind of hang out. So that's what I'm going to do. I'm just going to rewrite the x minus 4 here, okay? And I'm now going to find the product of this doing FOIL. X times x is x squared. X times negative 5 is negative 5x. 3 times x is positive 3x. And 3 times negative 5 is negative 15. So I did this using that first, outer, inner, last. All right, I'm still not doing anything with my x minus 4. I'm going to combine the negative 5x and the positive 3x to get negative 2x. Right, and then I've got that. Now that is really the equivalent of just multiplying the first 2 of my numbers together. I now need to multiply by x minus 4. Now we don't have any slick FOIL acronym for when we multiply a binomial by a trinomial. At this point we go back to the last 2 exercises where we have to decide whether or not we're going to multiply using area or whether we're going to multiply using double distribution. And I think for me I'm going to just stick with the double distribution for right now. All right, in order to do that, I will now multiply that trinomial all by x. So x times x squared minus 2x minus 15. And then I will multiply the trinomial by negative 4. All right. In this case, I'll have x times x squared, which is x cubed, x times 2x, which is negative 2x squared, negative 15 times x, which is negative 15x. Then I'll multiply everything by negative 4. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x is positive 8x. Got to be careful there. And negative 4 times negative 15 is positive 60. Again, be careful. Nothing combines with that x cubed. Here I have negative 2x squared and negative 4x squared. Put together, those are negative 6x squared. Here I have negative 15x. Here I have positive 8x. Combined, that will be negative 7x. And finally, plus 60. All right. And not surprisingly, right, this shouldn't come as a surprise. When I have an x times an x times an x, my final answer has a highest power of x cubed, right? Also not a great surprise that I have a positive 60, because negative 4 times positive 3 is negative 12, times negative 5 is positive 60. In fact, that first term really comes from multiplying all first terms together, and the last term comes from multiplying all the last terms together. The stuff in the middle, well, that combines in kind of cool and interesting ways that we don't really want to get into right now, but kind of come out in the wash as you're working through it. All right, what I'd like you to do now is pause the video and see if you can work out what that product is. It'll take a few minutes, so take your time going ahead and doing it. All right, just like before, what I'm going to do is I'm going to use FOIL and multiply these second two binomials out, and then I'll go through and do double distribution and multiply through by that last one. Here we go. So first things first, I'm just going to rewrite that 2x plus 3 down. And now I'm going to use FOIL to multiply these two together. X times x is x squared. X times negative 6 is negative 6x. 8 times x is positive 8x. And 8 times negative 6 is negative 48. All right, let's combine a few like terms in that second parentheses. Right, negative 6x, positive 8x is positive 2x. And then minus 48. All right, give myself a little bit more room. Now I'm going to do double distribution. I'm going to take 2x and I'm going to multiply it by x squared plus 2x minus 48. Then I'm going to do 3 times x squared plus 2x minus 48. All right, here we go. Let's distribute that 2x. 2x times x squared is 2x cubed. Give myself a little more space. That's not a negative. 2x cubed, 2x times 2x is 4x squared, and 2x times negative 48 is negative 96x. Whew, getting big here. 3 times x squared, well, is 3 times x squared. 3 times 2x is 6x. And 3 times 48, well, 3 times 50 is 150, so that's going to be 142. 3 times 48? No, 144. No. Yeah. Wait. Wow, that's not even close. 196? Wait. It's 3 times 48. Gonna be one of those days. 3 times 48, 24. I think I was right in the first place. 12, yeah, of course I was right, 144. All right, let's see. Now let's combine like terms. Nothing combines with the 2x cubed. 4x squared, 3x squared is 7x squared. Negative 96, positive 6 is just negative 90. And minus 144. Ooh. Sometimes I should just trust my sort of elementary school skills and go back to doing multiplication the old-fashioned way. All right. Again, very lengthy problems, easy enough to make an arithmetic mistake in this. Never hurts to have your calculator out. I just didn't want to bring mine out right away. So let's wrap this up. All right, multiplication of polynomials is a huge deal in math and in algebra. All right, we're going to use it for a variety of things as we move forward, and you will literally see it in every math class that you're in going forward, with possible exceptions of something like statistics. And even there, you might have to do it. Of special importance is this multiplying two binomials together, which is why we wanted to give you as many techniques as possible so that you could feel comfortable with one of them. Whether you use the standard multiplication algorithm, an area model, the FOIL method, or the double distribution really doesn't matter. If your teacher, of course, prefers one of those 4 methods over one of the other ones, well, you might want to stick with that because they're the person grading your tests or quizzes and whatnot, all right? But for us, it really doesn't matter which one that you use as long as you're able to do it accurately and quickly. Now, granted, you also have to be prepared to do things like multiplying a binomial by a trinomial, but that's something that you'll either have to use an area method for or sort of a double distribution for. We'll be using these skills as we move on in this unit and in this course. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.